All right, so I'm going to go around the room quickly. This is lesson set 5 and do a lot of repetition. I don't know how much I'll talk about concept here. The other lesson sets, I'm losing track what I've talked about already. I don't want to belabor the point, so we'll see as we go along. But one thing I'd like you to do, if you are following along, learn the e to the x and ln of x values here, approximations. We're making some gains with exponential functions. I think we're getting ready to talk about the graph y equals e to the x. But it would be very helpful if you started to memorize those numbers early on, and it'll help our conversations immensely. All right, so I'm going to go around the room. I'll put the computer down. Here are the first 7 problems. Writing the equation of a line, putting it in slope-intercept form and naming 3 coordinates, solving linear equations. A little more difficulty in that one. Perpendicular, something written in standard form, writing the perpendicular to that line that passes through the 0.57. Those are the first 7 questions, I believe, or 6 questions. Whole bunch more here. Got about 55 questions. So given a function evaluating f of minus 2, finding where f of x equals 11, simplifying a log or evaluating a log expression, completing the square, rewriting this fraction, finding the inverse of 1/3 to the x, getting good at multiplying binomials, and a little bit more continuation of working with square roots via factors. Sometimes we don't look at factors for square roots. We simplify them a different way. Vertex of a quadratic and another point. What's the equation? Solving this quadratic, evaluating another log, factoring, finding the roots of that after we factor, doing a little expanding, rewriting this in the ax squared plus bx plus c form. So I'm doing this so that you get a sense of where you might want to move through the video. Some of you, if you feel very confident with the equational line, it's going to be on every test. So you got about 12 tests during the term. I don't think you're going to forget it, but I'm going to give you it 12 times so you don't forget it for your next class. If you forget it for your next class, you haven't learned it. Sketching something in standard form. A little more difficult factoring problem. Solving something in factored form that's already in factored form. Finding a minimum y value for this quadratic. Finding the y-intercept for this exponential function. Looking at a composite g of f of 4. I've given you g of x and f of x. We're going to find g of f of 4. And we're going to find the inverse of 2x cubed minus 5. A little of this, a little of that, trying to get a working knowledge here. Kind of far from the board. Let me tip this down a little bit. Writing an exponential function, we want to be able to do this in 10 seconds or less. Writing a square root function, 10 seconds or less. Evaluating a little bit of negative exponents. Taking the inverse, the reciprocal of the cube root process. Solving an exponential. Solving a log. Solving another log that I wrote twice. Don't know why. I'll have to straighten that out later. So we're going to do 35 and 34 and call it one or the other. Okay, I obviously missed something on the worksheet. We'll just have to let it go. It's going to take a while to get this done. All right, finding 2 coordinates of this expression. If this thing equals a graph, y equals, I should say. Factoring this expression. Another exponential function, 2 points in an asymptote. Solving x cubed equals x squared. Solving a log again. Finding the roots if you have the vertex and the a value. And that's a 3-second question. Deciding what the best method is. We'll do 2 methods for solving this quadratic. Finding an exponential value, finding another exponential value. The precursor to long division in Algebra 1 is what we're going to study here. X minus 2 times what gets us x squared minus 5x plus 10. Most of them you want to do in your head. If y equals 916, how can we get an answer 4x squared minus 8x plus 11 if our y value is 916? And I got news for you. 20-second problem. All right, working with imaginaries. A lot of you are going to see those on your SATs. You work with I in electrical engineering, so all of those of you who are going to go out there and fix the electrical wiring in the building, good for you. Finding this y value if it's a right triangle, taking some words and writing the equation that comes from those words. Finding some coordinates for x squared plus y squared equals 37. What are the easy coordinates to find? And then we sketch linear, exponential, and quadratic function. And hopefully that we do this repetitively, we get a working knowledge. So let's get at it. Let's get a working knowledge. Let's start over here with problem 1. I don't think I'm going to talk too much about concept in this one. This is going to be too long a video as it is. All right, so I look at this and I say, well, my y values changed by 1. So that's going to be the rise. My 5 to 20 changes by 15. And then I can highlight 5, 8 by writing x minus 5 plus 8. And did I bring the eraser with me? Go figure. I got one here. I thought I had one. All right. So we're up and running. There's our first answer. Second problem. Name 3 coordinates. No, that's 3 coordinates. Write this in slope-intercept form. Well, we got to do the distribution. Minus 4 times x is minus 4x, and that then gets divided by 3. Minus 4 times minus 5 is plus 20. That gets divided by 3. And I got to add 2. Well, let's go back to elementary school math. We need a common denominator. 3 times 2 is 6. So that's 6 over 3. So what's my final answer? Minus 4x over 3 plus 26 over 3. That's a little practice. You're pausing the video each time. If you got a problem and you're not sure what the answer is, pause the video and have a go at it. All right, so that was 2 out of the way. Number 3. 3 coordinates. Well, from the last problem, I can tell you what I want to plug in there. I want to plug in -1. It's easy to work with. It's a user-friendly number. -1 plus 1 is 0. 0 times anything is 0. I get the 9. So I like equations written in the x minus h plus k format. Okay, and now I add x plus 1. I can look there to remember what I had. I'm changing my x's by 3. Well, why don't I change them by 3? I'm going down 10. Well, why don't I go down 10? And let's show why 5 gets you -11. If I put 5 in here, 5 plus 1 is 6. I do believe that is a multiple of 3. And I know how many times 3 goes into 6. And 2 times -10 is -20. Plus 9, lo and behold, we kind of knew that from the get-go. Okay, so you had a little practice there. 4x minus 5, I'm going to graph it just to get a feeling for what I'll make that -5. I'm going up 4 over 1. That's that line. I'm at -1 here, and I'm going over 2 and up 5. I think, boy, I'd have to be on graph paper. I'm not going to graph it. Okay, I know my answer is pretty close to 0. I think it's on the negative side. I'd have to do a better job at graphing. But why don't we multiply? I don't usually give a fraction here on these problems, but I did. So yeah, what's the easiest way to do this problem? I'm going to multiply by 2. 8x minus 10 equals 5x minus 1, minus 2, excuse me. I'm just going to double everything. Get the fraction out of there. All right, now it's easy to solve. So I'll bring the x this way. I'll bring the number that way. Add 10 to -2, I get -8. And so x was -8/3. So my original assessment on the graphing would have been fine until I fooled with it and made it go the other way. So small negative looks good. All right, so now we actually get a repeat of a process. Here I'm going to take -2/3 x minus 4 equals 5x over 2 minus 1. I'm going to multiply everything by 6. Because I know what 6 divided by 3 is. And I know what that times -2x is. And I know what 6 times -4 is. And I know that 2 goes into 6 3 times, so I can make that 15x. And if I don't get tired, and I will by the time I get to problem 55, let's see how I do. -6. All right. I'm going to bring the -4x this way, so I don't have to divide by a negative. I'll bring the 6 this way. That appears to be that. So it looks like it's -18 over 19 for an answer. All right. I might as well get the answer key. Nah, that way I could check to see how many careless errors I made on this, because I don't write anything out. I do them in my head. And I usually make 2 or 3 mistakes. Let's hope I didn't make one there. All right, so now we've got this problem here. Can we see it? Yes. 7x plus 3y equals 400 through 5, 7, and I want the perpendicular. So I'll make it go through 5, 7 first. And when I look at this, I already know the answer, but we'll show you why. So we're going to move the 400 doesn't have anything to do with the problem. It's the interplay of these two numbers. So 3y equals minus 7x. So what does y equal? Y equals minus 7 over 3. That's our ratio of change. If I go over 3, I go down 7. I've got a line that looks like that. The perpendicular has to go in the other direction. I hope that looks perpendicular. And if I measure that, it turns out, so this first one was over 3, down 7. This one looks like it's going over 7 and up 3 if I drew it better. Okay, because it's the negative reciprocal. So what's the negative reciprocal of minus? I got to flip it and change the sign. It's that. And a lot of times when you put your answer next to the original problem, you can start seeing where the answer comes from. I suggest you do that because probably more than anything else, the most important thing coming out of this class is looking for patterns. All right, can we see everything? Not really. I hope I remember to put computer down a little bit. When I get here, I'll check again. So I gave you a function. I'm going to multiply -2 times 5/3 and add 4. So this is equal to 5/3 times -2 plus 4. That's minus 10 over 3 plus, what do you think 4 is in terms of thirds? I hope you say 12 over 3. So our answer is 2 over 3. That's what I get when I plug -2 in. I can erase that. Now I have f of x equals 11. Well, f of x is this calculation. I want to know when it equals 11. Well, the first thing you can do is move 4. Next thing I'm going to do is multiply by 3. I don't like multiplying by the reciprocal. It's easier just to do it this way. 21 over 5 is your answer for that problem. Subtract 4, multiply by 3, divide by 5. That takes care of that. Can't evaluate this if you don't know what it's asking you to do. First day of class, we looked at log of 8. That means I'm looking for the exponent on top of 8. That gives me 1 over 32. I'm trying to expose you to multiples of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this could have been written as 2 to the -5. I think we've done that enough that I can get away with saying that. 8 can be written as 2 cubed. And if I move that exponent above that parentheses, I get 2 to the 3x equals 2 to the -5. I think we can see our answer now off to the side. 3x has to equal -5. 3x has to equal -5. Therefore, x is equal to -5/3. Now, what does that 3 mean? It means I'm taking the cube root of 8, which is equal to 2. I've done that operation. Now I'm going to put -5 above that 2. Lo and behold, 1 over 32. Get rid of that. X squared minus 8x plus 3. Well, we got to look at something conceptually now, I think. Let's start with 3 by 5. That's a rectangle. Gives me 15 units of area. I could have expressed it as a 4 by 4, which gives me 16, and then subtract 1. This is a rectangle, x squared minus 8x. X squared minus 8x is x times x minus 8. This should have been x minus 8. It's shorter than that, but I've already got a drawing here. That's a quadratic that passes through 0 and 8. That get me, in this case, 3. But if I want to make a square, I got to find the number between 0 and 8. It happens to be 4. So let's have at it. X squared minus 8x. I'll just show you the mechanics. We'll be talking about it all term. And this is going to allow us to study conic sections, circles, ellipses, hyperbolas, etc. I could have written this as, it's easier if I do it underneath. First off, I basically, when I had the 0 and the 8, I was looking for the number in between. And I divided by 2. So I could always get this thing to be a 0. So I just got to divide that number by 2. At least when the coefficient is 1. I probably should say that. Okay, so x minus 4 is getting squared. We are trying to get good at this. X squared minus 8x plus 16. That's different than x squared minus 8x. But to get rid of this 16, I could do that. Then I could add 3. And so what is x squared minus 8x plus 3? It is x minus 4 squared minus 13. Now I can see the vertex. 4, 13. I know I got an a value of 1. I got the roots, immediate roots here. I've got 4 plus or minus the square root of 13 divided by 1. Imaginary. Was it negative? Oh, it's negative 13. So it's not imaginary. Okay. Yeah. So once we get good at completing the square, we can do tons of different types of problems. All right. And you can replay that. I know I'm going fast. Modern technology. All right. So why is this on here? This is on here because I've seen people do 6 plus 4 divided by 4 is 6. When do I see that? I see that when I have x squared plus x cubed divided by x cubed. And people do that. You're basically doing the same thing here. That's a big mistake. Division does not undo addition. One of the reasons we learn factoring is so we can do, division, because we can write sums and differences as products. Then we can do inverse operations. All right, so I want to make sure that you know that this could have been written as 1 over, let's do it this way. 8 plus 7 divided by 2 is the same thing as 1/2 times 8 plus 7. They mean the same thing. So we always talk about distribution with multiplication. Well, division is a form of multiplication. So why don't we do the distributive property of division? That could have been written 8 over 2 plus 7 over 2. Right? That's how that fraction could be rewritten. All right, so how do I rewrite this fraction in front of me? Well, I got to redo a reduction. 5 goes into 15 and 10, so I have a 3 over 2. I have more x's in the numerator than the denominator. It looks like I have 4 more in the numerator. I have a subtraction symbol. 2 goes into 10th, 1/5. And it looks like I have more x's in the denominator than the numerator, and I can count. Now, what allows me to do x to the 11th over x to the 7th so that I can call that x to the 4 over 1? And I don't need the 1 there. Well, x to the 11 could have been written as x to the 4 times x to the 7. And now I can see the cancellation there. All right, moving right along, we'll continue to talk about that until everybody in the class can do that easily. Then, well, doing it easily, I guess you're doing it well. So what is the inverse of 1/3 to the x? Okay, keep talking about it in class, and got to keep talking about it till it resonates. It's log base 1/3 of x. Those are inverses. How do we check an inverse? Well, we were working with numbers. I meant to show something a little earlier working with numbers, and I forgot to. Let me get back to it. X squared minus 8x plus 3, we said was x minus 4 squared minus 16 plus 3 minus 13. Put any number. Algebra is this. If I'm right, I can use any number. And when I plug it in this side, I'm going to get table values that are exactly the same as that. Now, what would be an easy number to work with over here? This is the harder side, I think. Well, I'm going to pick a 5. 5 minus 4 is 1. 1 squared is 1. 1 minus 13 is negative 12. 5 gets me negative 12. If I put a 5 in here and it doesn't come out as negative 12, then I'm going too fast and I got to go back. 5, 25, minus 40, plus 3. Minus 40 plus 28. Yep, negative 12. 5 got me negative 12. I could keep doing that, but I spent a lot of time. So I think we're good. So what would be a nice number for you to use? Well, I think I'd put a 2 here. 1/3 squared gives me 9. That's my x, that's my y. What's the inverse of 2 to 9? 1/3 squared, of course, if I did it right, that would be better. 1/3 squared is 1/9, excuse me. All right, maybe I should have picked -2. All right, let's do that. -2 is 9. I'll go that route. 1/3 to the -2 is 9. I've got to flip it and square it. All right, and if I put a 9 in here, I'm asking the question, 1/3 to the what equals 9. Okay, over here, I think that's a 2. So this x gets me that y, 9 gets me 2. Over here, a -2. I did it again. Okay, can I get through a video without making a careless error? I doubt it. Okay, so a 9 gets me a -2. Over here, a -2 got us a 9. Hope you get a little feel for the inverse. All right. Okay, going fast because a lot of problems, you can always replay things. Okay, so we got, well, I just did that one. So 3x minus 10 squared. Let's do 5 minus 2 squared. And what I'm suggesting is you square the first number, you do the product, 5 times -2, -10, and you change and you double it, and you take the last number, and it's always going to be positive when you square it. I think I get 29 minus 20 is 9. Oh, 5 minus 2 is 3, and 3 squared is 9. Boy, that shortcut works. I take the first term. What do I do with it? I square it. I take the product, 3x times -10, which is minus 30x. I double it. Then I square the last number. And this is supposed to work for all numbers. So what would be a good number here? I think 4. I like working with positives. So 12 minus 10 is 2 squared is 4. Did I really want 4? 16 times 9. Well, I know that's 144, so I can get away with it. 4 times this is minus 240, and that's 100. 144 plus 100 is 244 minus 240. Boy, they are the same. Yeah, I'm getting the same answer. When I plugged in 4, I got 4 out. And when I plugged in 4 here, I got 4 out. I bet I didn't make a mistake. All right, √3 times √33. We explained that in the last lesson set. You want to write that as √3 times √3 times √11. √3 times √11 is the same as √33. Previous lesson said, I know we talked about that. And I know what the square root of 3 times the square root of 3 gets me. Gets me 3 by definition. So this becomes 3 √11. I do not know what √11 is. Somewhere between 3 and 4. That's about all I know about that number. All right, square root of 32. No reason to do any factoring here, because there's a nice perfect square sitting inside that number, and it's 16. And I know a better name for the square root of 16. 4 √2. And I've been asking students to memorize √2 and √3. And our memorization is 1.41. Remember that? I see something other than 1.41. Yeah, I know what that means. And I know the square root of 3 in our class is 1.73. That's what we're going to work with. And why do I want you to know those? Because you are big time going to be working with these numbers in trigonometry. And if you don't have a feeling for size, you don't have a feeling for the calculation. All right. So √32 is equal to 4 √2, which is 4 times 1.41. So that's a 4, that's a 6, that's a 5. So it's approximately 5.64 off a calculator. I'm close enough. All right, vertex, -5, 7, 17. 17 goes to 6. That's going down. My x's are going up. I have a concave down shape. And I know that the vertex is -5, 17. And I know it goes through 1, 6. Well, I know if I'm going to show the vertex, I got to get 0 squared. It's the smallest area a square can be. So -5 has to act like a 0. So I'll say x plus 5 squared plus 17. And now I know that this thing, whatever comes out of this, when I add it to 17, better get me 6. So let's put a 1 in. 1 plus 5 is 6 squared is 36. Yes, 36 plus 17 does equal 6. No? Oh, then let's get rid of that 36. What plus 17 equals 6? I think minus 11. So let's get rid of the box and show the answer. Well, becomes a 3-second question once you figure things out. If you go over 5 units to 1, you have linearly changed by 6 units. But this is a quadratic. The quadratic changes that number into 36. And if that number doesn't work to take you to your next destination, you better convert it into something else. I want to keep having you hear these conversations until you can do that in 3 seconds or less. Solving this, well, we don't need to do anything here. We can do inverse operations. I've got addition, multiplication, and squaring. So subtract 2, 3. This is in graphing form, by the way. This is the same thing as x minus 0 squared plus 2. A lot of 2's in that problem. Okay, so what I'm really looking at is a quadratic that's going up a little more quickly from 0 to. And I want to know when it hits a height of 5. Sure looks like it's some small positives and small negative numbers. So subtract 2, divide by 2, and then take the plus minus square root of 3/2. Remember, we had something that had a positive and a negative answer. Oh, there's one of our memorizations. It's on your sheet. Plus minus, what's the square root of 3 over 2? I'm using 0.87. But let's see if it actually works. Let's double our answer. Plus minus the square root of 3 over 2. Was it 3? Was the 2 inside? I forgot. Oh, the 2 should have been inside. I butchered that. Okay, so let's not do this. But let's check that answer. Because checking it would have found the mistake, and that's a big part of mathematics. So I am going to take the square root of 3 over 2. I'm going to square it and add 2. And let's see what we get. Well, we got to do the squaring, which gets me 3/2. Then I can see the 2's cancel. Then I get 3 plus 2, which, oh, coincidentally is 5. All right, so at least I'm catching my mistakes a little quicker. But I'm only not even halfway through this. And, you know, if I was doing it, I wouldn't have to do anything. I'd just put an answer here and just keep going. But this is exhausting. So log 1/4, we talked about it earlier. That's asking the question 1/4 to the what equals 64. And I know 1/4 to the x is the same thing as 4 to the negative x. Got to reciprocate it. And I know 64 is 4 cubed. And that's why I knew this answer was -3. And I hope you do too. All right, some basic algebra 1 factoring skills here. What 2 numbers multiply? Because this is a coefficient of 1, we can't do it. It's not a coefficient of 1 the way that I'm going to explain it right now. What 2 numbers multiply out to be 16 that are 6 apart? 2 and 8. So you can get the 2 and the 8 right here, right now. Who wins the battle? The negative. So Mr. Big is -8. And this one's positive. And that skill is useful because if we're trying to find the roots, which is the next question, then we're setting it to 0. I can see my user-friendly numbers. I got a cup shape up because it's x squared. I can see over here -2 gets me 0. And I can see over here 8 gets me 0. And that means I can find the number in between, which is going to be 6 cut in half, 3. And if I square that, I should get -9. I've done enough of these that I think that's going to work. So let's do it. No. Did I make a mistake on this? Yeah, I probably did. 3 plus 2 is 5. 3, oh, I should have put it in first. Okay. Because I knew I got a square. So it's -25. All right. And rise over run squared should get us 1. Because x times x is x squared, and the number in front of it's 1. So how far is it from -25 to 0? I have to go up 25. What's the squared change from 3 to 8? From 3 to 8 squared. 25, there's my 1. Rise over run squared as measured from the vertex. All right, let's get rid of this. Give me a moment to collect my breath, my thoughts. So we have 9 minus 6 times x minus 2 squared. So I'm going to put the 9 at the end. Because I want to make sure nobody does 9 minus 6 and says 3. Because you do hardest operation first, which is squaring. Multiplication is the next hardest. And adding 9 at the end is the least hard operation. So I like to do these in my head. I know x squared times negative 6 is negative 6x squared. I know doubling that is minus 4x times minus 6 is plus 24x. I know negative 24 plus 9 is negative 15, I think, but let's check. Let's do the binomial squaring. X minus 2, I square the first term, I double that product, and I square the last term. So there's my 6x squared, there's my 24x, there's my 24 plus 9. If I added that correctly, we're done with that. Okay, a lot of hard work here to build the foundation, but the goal is, come final exam time, you don't have to do any work the night before the test. You just go in and say, I know this stuff cold. That's if you do it all the time. Sketching 4x minus 3y equals 15. Standard form. Hey, you've heard me say this now 3 or 4 times in a row with the lesson sets. How do we graph standard form? X and Y intercepts. The x-intercept is 15 over 4, which is a little bit more than 4, a little less than 4 units. So that's 15 over 4, comma 0. If I'm subtracting, I'm going up. So how many times does negative 3 go into 5? Negative 5. So 0, negative 5. There's my intercepts. There's my line. So you don't have to change this at all. You should be able to work with zeros because these are products. 4 times x is a product. It's a single term, but it's a product. And you want to make products equal 0 because you get useful information. We're going to make this into a product and get some useful information. I sure as heck know that it's a cup shape up. Well, yeah, don't really. Well, yeah, this is just a variable. I can say that. So we're going to do 2a times a for starters, so we can get that first term right here. And I got to get 2 numbers that multiply out to be 15, but also those 2 numbers add up to minus a. No, it's not those 2 numbers. I didn't want to say that because I'm doubling this foiling process right here. So I have numbers like 1, and if I put a 1 there, then I got to have a 15 over here. If I put a 2 here, I've got to have a, I'm sorry, if I put a 3, I'm trying to get 15, right? If I put a 3, I got to have a 5 here. If I put a 5, I need a 3 here. And if I put a 15, I need a 1 here. But each of these numbers is, what's going to happen to each of those numbers? They are going to get doubled. So I'm really looking at 2 and 15. Nah, 3, 6 and 5. Oh, 6 and 5 get me 1. Right? So bingo right here. All right, so I'm going to put a 3 here. I'm going to erase this. And you can't get good at this without practice. And you can't get practice without doing problems. So can you see 3 times 2 is 6 and 5? And I think it was a minus a going on memory here. That's terrible. So I want that one to be negative, that one to be positive. I mean, we can do factor by grouping, but we want to practice calculating. All right, people who calculate well move up the ladder well. So we want to push the brain. Let's calculate. All right, but not on the next problem. On the next problem, we just want to answer. We want to answer length times width times height equals 0. That's really the evolution of the discipline, dimensions. So how do I make 2x plus 1 equals 0? Because if it equals 0, I've got no box, no volume, because this is, 3 dimensions. Well, it's actually not. It's 2, 3, 4. It's a 5-dimensional picture, which I can't draw. But you can think of it as 3 factors, right? So what is going to make 0 in each case? I can see that one, minus a half. I can see that one, 9 over 23. And I can see that one is 0. So those are the 3 x's where this thing is going to, it's next to the 5th graph. I'm not going to try to graph that. But I've got 3 roots at 0, 9. So I got 2 more imaginary roots if I really did this out. Now I'm rambling, so I'll shut up. All right. What did I ask? Oh, minimum value for this. And the y is the minimum. Okay, where will the minimum y be for a problem like this? Oh God, yes, we just have to find the vertex. So 24 divided by 4 is 6. I'm going to plug 6 into this right here. 36 times 2, 72. So I know I'm going to get minus 72 minus 1, minus 73. There's a shortcut. Bang. Now, how did I know that? All right, so remember the number 6. Erasing this, that's your answer. If I do 6, 36 times 2, 72. This next answer had better be minus 144, or I did something wrong. Because only at the vertex will you get that 2-to-1 opposite ratio. In a cubic, it's 3-to-1 opposite for the point of inflection, planting a seed. And that makes minus 72, which is actually half of that, or the opposite of this. I did the opposite of that this time. I could have done 6 times 24. You know, I just didn't want to do that. 120 and 24, 144. All right, didn't feel like doing that. All right, so finding a y-intercept simply means put a 0 in. Hope you're keeping up with me by pushing this pause button. All right, so I have 2 to the negative 4 plus 3. That's 1 over 16 plus 3. Why don't we write it as 3 and 1/16? G of f of 4 is how you might see this on your SATs. So I got to do f of 4 first, which means I'm plugging 4 into the square root function. And I can see that that's equal to 5, square root of 4 plus 3. Then I got to take that 5 and plug it into the g function. And that gets me 125 after I cube it. Times 2 is 250. Minus 5, 245. Now, I don't remember writing that on my answer key. Well, I hope I did. Otherwise, I got to get a pencil out. Anyway. Getting there. Hope I don't run out of battery. Let me see what I got for battery here. See if no, I'm good. Otherwise, I'd have to start really going fast. All right, so we practiced this in class today. We did a lot of work with this. So y equals 5. What's your first differential? Your first differential is from 5 to 9. Get that 9 over here so everybody can see it. From 5 to 9 is a jump of 4. And from 5 to 17 is a jump of 12. Does that look about 3 times the size of that? Because I did a cooked problem here. And guess what the base of this exponential function is? It's the second differential divided by the first. 12 divided by 4. Because the numbers might not always be so nice. Right? And what do I have to put in front of that 12 over 4? The first jump. That initial jump. Now I'm done with the y's. I got to look at the x's. 1907, we're going to turn that into a 0. So now when I drop 1907 in, this is going to work for 9. Let's do it and see why. 1907 minus 1907 is 0. Anything to the 0 we talked about in previous lesson sets is 1. And so therefore, I get this number turned into the number 1. Times 4 is 4 plus 5. Bingo, 9. The next thing we want to do is b to the 1 because we know we get b. In other words, if I can make this expression 1, that's going to become 12 over 4. But I got to plug 2,000 in this time. And 2,000 minus 1907 is actually 93 years of elapsed time. And so if I do 93 over 93, I get something to the 1. 3 times 4 is 12 plus 5, 17. And we're beginning a nice discussion about exponentials. Now, if I change the x's and the y's, this is actually a square root problem. It's got a beginning and slow growth. So let's look at the square area here. The smallest square area I can get is 0. So if I have 0 for an area, then on the square root, I have the square root of 0. If I have 1 unit of area, the square root of 1 is 1. It takes 4 units of area the next time to get the square root of 4, which is 2. 0, 1, 2. I bet my next number is going to be 3, which is the square root of 9. So I start at 0 and I get 0. 1 unit of change, I go up 1. 4 units of change, I go up 2. 9 units of change, I go up 3. And I hope you can start to see that trajectory. Just barely, I captured it on the screen. So we have so far linear y equals a x minus h plus k. We've got quadratic a x minus h squared plus k. Any ideas what the square root's going to be? I hope you say we have a square root of x minus h plus k, and you'd be right. So what's hk? Hk, the most important point on that curve. Square root of x minus 4 plus 7. Notice I didn't do any square roots of negatives. They're not going to show up on René Descartes, which is not in this room. It's in a different room, but I kind of like this one now. I might be retiring René. All right, so drop in a 9. When you drop in a 9, you got to do the whole calculation to find out if it takes us to 30. The square root of 9 minus 4 is the square root of 5, and the square root of 5 plus 7 takes us to 30. Okay, we're done. No, we're not. You're right. Get rid of that. Let's get rid of this by dividing it by the square root of 5. But I'll do it over here. And I can figure out what takes from 7 to 30, 23. That's that equation. All right. Where I don't think I've talked a lot about simplification of negative exponents. So what is m to the minus 6? M to the minus 6 is really m to the 12 divided by 1 over m to the 6th. I could rewrite that as m to the 12 divided by 1 over m to the 6th. When you divide by a fraction, you multiply by the reciprocal. So I'm going to do m to the 6 over 1. So what do I learn from that? I can move negatives into the other position as positives. And so what is m to the 6 times m to the 12? M to the 18. Feel free to, we're going to keep doing those in future lesson sets, but if you want to replay it, go back. I know I'm talking fast, but replay it. Slow it down. 1/8 to the negative 3. Be nice if you knew what that 3 stood for. I thought somebody was out in the hall. Okay, that's a root. Okay? I think I would flip this first, because the minus sign means I could. So 8 to the minus 1/3 is the same thing as flipping 8 over 1. No, I wouldn't flip it. Oh, it was 1 over 8. Okay. Yeah, I'm getting tired. That was the original. Okay, so I am going to flip that, which means I can make it 8 to the 1/3. And that's not dividing 8 by 3. No, this is a root. Roots undo powers. Roots undo powers. If I had a 2 here, that means square root. Squaring, square rooting. Cubing, cube rooting, etc. I know what the cube root of 8 is. This is the same thing as this. And I know that's a 2. Okay. Math is a language. You have to know what is being spoken. The only way you get that is to keep talking about it till you own it. Keep trying it till you get it. All right. Inverse operations, no reasons we can't do inverse operations here. I'm going to take away 7. Well, let me write it up here. 3, 2, x minus 4 plus 7 equals 11. I'm going to subtract 7. I'm going to divide by 3. And now I'm at 2 to the x minus 4. I think I'm looking for the value of an exponent. I wonder if you've heard me say that the first week. I'm looking for the value of an exponent. Yes, that's what logs are all about. So, in order to get that value, I have to use the base 2, 4 over 3. Now, I can actually get that to some pretty good decimals without a calculator because I know the e to the x values. Maybe I should show you how to do that. We talked about it in class for the first time today. 2 is really e to the 0.7 approximately, and I'm raising that to the x to figure out 4 is 2 squared, and 2 is e to the 0.7. And so I'm squaring that, and I'm dividing by 3, which is e to the 1.1 approximately. So this becomes 1.4 minus 1.1. That becomes e to the 1.4 minus 1.1, 0.3. 0.7x, therefore, could equal 0.3. And I've got x equals basically 3/7. There's an approximate answer to that problem without a calculator. Now get a decimal, you go put that in, see how close it is. It's not great, but it's a feel for the number. That's all we're trying to get there. All right, and because we talked about E today, I felt obligated to show you where we're headed. Oh, I never did add 4, did I? I don't think I added 4 here. 4 3/7 is my answer. Yep. All right, no major mistakes, little ones here and there, but I'm satisfied. That's okay. Getting some progress here. Log 1/4 to the 2x equals 2. Pause the video if you want. I know I'm looking for an exponent again. I'm looking for the exponent on top of 1/4 that gets me 2x. Oh, you know what? I don't have to go looking. It's right here. Oh, that is the exponent. Oh, wow. So 2x is equal to 1/4. That's the base. That's the exponent. So 2x equals 1/16. And I know multiplication becomes division on the other side. Oh, that's 1/32. So if I put 1/32 in here, we should be able to see it. I double that, that makes it 16. What exponent do I put on top of a fourth to get a 1/16? I got to square 1/4. I got to take 1/4 and square it. If I do, I get the number, the quantity I was looking for. Woo! Boy, oh boy. How much can we learn quickly? Well, we're going to find out. Best I ever saw at the Algebra 2 level was 102 questions. Young woman did it in 39 minutes, and she got 101.5 for a score. That's pretty good. All right, 2 coordinates. Number 36 is a function, and I want to know 2 coordinates, 2 user-friendly numbers. Okay, you're looking at that. This is multiplication here, right? So I want to make one of these a 0. Well, I can't make the constant a 0, but I sure as heck can make this a 0. I can see x equals 4 will get me y equals 5. You put 4 in here. 4 minus 4 is 0. The cube root of 0 is 0, because 0 times 0 times 0 is 0. 0 times anything is 0 plus 5. I can see that. Sure would be nice if I could get 8. 3 plus 5 is 8. Would be nice. Of course, this would have to cancel. So I guess x minus 4 has to equal 7. Oh, I guess 11 does it. I'm running out of ink. 1 lesson set. My goodness. All right, so now we want to factor. And the first rule of factoring, you're going to hear me say this all semester. Take out what's common. Take out commonness. Not a communist. Take out commonness. All right, 8 to the 4, 8 to the 6. Let's just look at 8 to the 4 and 8 to the 6. 8 to the 4, 8 to the 6 could be written as 8 to the 4 times 8 to the 2. What do these 2 expressions have in common? The smaller exponent. So what's another way of writing this? Well, what do 8 and 10 have in common? 2. What do 8 to the 4 and 8 to the 6 have in common? 8 to the 4. What do x to the 5 and x to the 7 have in common? X to the 5. Now I should be able to build it back up to get 8a4x5. Well, I already have the a4x5. So 2 times what gets me 8? Simply 4. And then I'm subtracting. 2 times what gets me minus 10? 2 times negative 5. And now I have 8 to the 6th. I've got already 8 to the 4 built into this multiplication, but I got to get up to 8 to the 6th. I think we're looking at a squared. And I got to get to x to the 7th. I think we're looking at x squared. That's how you do that problem. Now we're going to write an exponential function, a model, but we have the data in front of us. But the same thing, how do I get from 3 to 7? And how do I get from 3 to 11? That's going to be the base of the exponential function. 3 to 7 is a jump of 4. 3 to 11 is a jump of 8. I have a doubling, kind of a doubling function on top of 3. Not exactly that. What was my first jump? 4. And everything is above 3. Okay, so I have exponential growth, 1920. Why don't we use t minus 1920? All right, so when I put 1920 in, repetition, I get 0. 2 to the 0 is 1, times 4 is 4, plus 3 is bingo. 2021 is 101 years later. So if I put 2021 in, minus 1920, I get 101 divided by 101, which is 1. So 2 to the 1 is 2, times 4 is 8, plus 3 is 11. Wow. And I think if I went up 4 and then 8, and I'm doubling, I think the next one's going to be 16 as a jump. And then I think the next differential is going to be 32. So 4 doubled, 8 doubled, 16 doubled, 32. Woo! In the future, I'm heading in that direction. In the past, 4 becomes 2, becomes 1, and I'm heading to y equals 3. Oh, it's starting to look like a Jackson Pollock here. All right, but it's early in the semester, and I just want to make sure that we're planting some seeds. That's out of the way. How do you solve x cubed minus equals x squared? Well, one of the rules of solving equations is getting your variables together. So I want to put x cubed minus x squared on the left. And anytime I see a 0, I'm going to look at a sum and a difference, and I'm going to ask the big question, can I write it as a product? Of course, nobody's going to say it that way. They're going to say, can you factor it? Okay, but can I write this as a product? Well, I wonder what the first rule of factoring is. I don't know if I said that. Oh yeah, take out what's common. X squared times x minus 1 equals 0. I now know what the graph looks like. Right there, positive 1. I got a cubic that looks like that. I hope you know what it looks like later on when we start graphing these things. But what are my answers? My answers are 0 and 1. If x equals 0, yeah, 0 cubed equals 0 squared. And if x equals 1, 1 cubed equals 1 squared. Very good. Now x cubed looks like this. I'm going to really, can I show that any better? I don't think so. Why? Yeah, I can. Can I? If you cube a half, you get an eighth. If you square a half, you get a fourth. That number's bigger than this. So when we get past 0, the cubic actually stays lower longer. The quadratic, it's not easy to explain here. The quadratic's underneath and then comes up, but goes up more. Forget it. We're at that stage where I'm getting silly. So you put it in a grapher and you're going to get a better graph than I'm doing right now. All right, so I took care of that one. Next question. Sure as heck not going to start this video again. 3 log base 5 x minus 5 plus 4 equals 1. Just going to do it quickly. Subtract 4, divide by 3, do 5 to the negative 1, call it 1/5, add 5, 5 and 1/5. All right. So the inverse of logging base 5 is exponentiating base 5. What's the inverse of exponentiating? Logging. What's the inverse of logging? Exponentiating. When do we use inverse operations? All the time. 90% of the equations we're going to solve this term, rough estimate, we're going to use inverse operations. So we want to get good at it. All right, I got a difference here of several terms, but it's set to 0. Geez, I wonder if I can factor it. Oh yeah. X minus 11 times x plus 5 gets the job done. And now I can see my answers are 11 and negative 5. Hey, I'm not gonna do any concept now. It's really getting tired. All right. So what's the exponent I put on top of m to get 1 over m to the 5? Negative 5. M to the negative 5 can be written as 1 over m to the 5. Then I'm looking for the exponent. There it is. So I could have rewritten this as m to the minus 5, and I'm looking for exponents on top of m. I think I spot one. Can you spot the exponent here? Hope you say minus 36. Precursor to long division in algebra 1. Be nice if you knew what you were doing. So I'll try to help you see that. So x minus 3 gets us the first two terms, right? But minus 2 times minus 3 is positive 6. How do you get from 6 to 10? Well, you got to go up 4. But if I multiply that by x by, I don't see 4 being multiplied by x minus 2 anywhere, so I'll get rid of that multiplication with that division. Right. Now, let's see if it really works by plugging in a number, a friendly number. I'm going to use 2. Well, it's undefined here, so hang on. Let's see. Let's use 3. 3 minus 2 is 1. 3 minus 3 is 0. 3 minus 2 is 1. So I get 1 times 4. I get 4. Okay. Textbook would have us use 2. And the reason is I could move this to the outside, and it's also another way of writing that. It's easier to see it when it's written this way. But we'll just check this for now, right? Because it's getting late, and I got another duty here tonight. I want to make sure I get this done. So if I put a 2 in here, I get 4. I hope everybody can see that. So let's just put a 2 in here. We get 4 minus 10 plus 10. Well, the 10s cancel, and I get 4. That's just a quick way to make sure you didn't make a careless error. And I'll elaborate on that as we move into different problems. So I'm trying to figure out how to solve this for 916. A young woman in class today said, can I use the quadratic formula? Sure. Do I want to use the quadratic formula on that problem? No. I know the A term is 4. And if I know I get the vertex here, I got the roots. So how do I get the vertex? Minus b over 2a, which is 1. And therefore, I know my x is going to move from 1, because 1 is not going to get me 916. But what's going to get me 916? Let's put a 1 in and find out. So 1, well, not going to get it. So that's 4 minus 8 plus 11. That's minus 4 plus 11, which is 7. Okay, so I can figure out how far is it from 7 to 916. That's what I really need to know. How far is it from 7 to 916? It looks like it's 909. That's the number I need. That's the number I need. And that's the number I need. So my answer should be 1 plus or minus the square root of 909 over 4. Now, it took me longer to do that than normal because I'm talking to you and I'm tired. But that's a whole lot quicker than doing the quadratic formula. Right. Now, where are we? Well, we probably should check that, huh? Let's see if that does work. 4 times the quantity. 1 plus or minus the square root of 909 divided by 4 plus minus 1, right? Because I could have written this as 4 times x minus 1 plus 7, right? Squared, right? So I got to square this. I got to add 7, and I got to see if that equals 916. All right, let's do the math. What happens to the 1s? They cancel. What happens when I square this quantity? Plus minus is positive. The square root disappears. What happens when I multiply by 4? Cancels, and I get 909 plus 7. Oh, wow, nice coincidence. Imaginary, as you'll see on your SATs quite a bit. So let's multiply this out. 5 times 2, 10. 5 times minus 4i minus 20i. 3i times 2, 6i. 3i times minus 4 minus 12i squared. I hope everybody knows that minus 12i squared becomes positive 12. I hope everybody knows that 10 plus 12 is 22. And I hope everybody can do minus 20i plus 6i minus 14i. Did I capture that on the computer? Getting a little better. Yep, I did. SAT work. Okay, we just started doing these in class. Remember, it's important to remember I squared is -1. I don't know if anybody's going to remember the textbook method, you know, the 1, 2, 3, 4 method. I think this is a far better method. It works a lot of different concepts, and let's see what they are. So I can write I to the 29th as I squared. I've got to get up to 29, so I've got 14 takes me to 28, and I build another multiplication of an I in there, and those are identical statements. And we talked about -1 to an even number times I. Right? -1 times -1 times -1. Is there a pattern? Yes, there is a pattern. If I do it once, it's negative. Twice, it's positive. 3 times, negative. 4 times, positive. An even number of times, this is going to become +1. And so our final answer is 5i. We do that every day till May. I think we're going to get it. All right. Mathematicians do not like i's in the denominator. I think this is probably the reason why. How would you write these two? How would you state these two fractions? I have no problem saying I'm cutting I in half. How do you state what that is? Go ahead and try. So we move the imaginaries out of the denominator with a little trick called the conjugate, changing the verb tense perhaps. 7 plus 2i. And when you get good at it, you'll know that that thing multiplies out to be 53 without even looking. But we'll do it out. 3 times 7, 21. 3 times 2i, 6i. 5i times 7, 35i. 5i times 2i, positive 10i squared, divided by 7 squared, 49. 14i minus 14i plus 2i times 2i, a negative times positive, -4i squared. We're always going to get a negative square. If we always get a negative square, then what happens to -4? Always becomes +4. What's always going to happen to the two inner terms? They're always going to cancel, and I get 49 plus 4, which is 53. In the numerator, positive 10i squared becomes -10. 21 minus 10 is 11. 6 and 35 is 41i, and that's over 53. Okay, that takes care of this. The missing side length for this triangle, we have 3, which means we have 9 square units. We have y squared units, and we have 8, which is 64. 64 minus 9 is 55. So what is that length? Square root of 55. Now, I think there was a distance question here somewhere. Maybe that's the one I missed. Yeah, distance, this is a distance, yes. The distance. So, you know, if you've got a place 5, 1, moving to another spot, let's say 9, 2, well, you can draw a triangle. 5 to 9 is 4, and 1 to 2 is 1. You should be able to find that hypotenuse pretty easily. I think I missed that problem somewhere along the line. Almost done, thank God. All right, $50. Doubles every 19 years, starting in the year 2007. And I've churned those words, which are written on a piece of paper, better than I did here. Running out of marker. X squared plus y squared equals 37. Geez, what do I see? I'm seeing 37. I'm seeing, no, I'm sorry. I'm seeing x squared. I'm seeing y squared, and I'm seeing that area 37. I wonder what I would get if I made a 0 here. Kind of looks like those 2x plus 4y equals 24 type problems. And we put in a 0. We put in a 0. X squared's a product. It's x times x. So what number should we put in here? 0. And if I put a 0 in there, y squared equals 37 plus minus the square root of 37. I got 2 coordinates right now. I'm done. But it's also true that y squared is y times y. And if I put a 0 in there, I get plus minus the square root of 37. And now I'm showing the instructor I got 4 coordinates. I got 2 more that are a gift. Now, as soon as you start moving away from 0, what you're going to start to get, if you looked at x squared plus y squared equals 1, you get the unit circle. You try it. This coordinate's going to be 1, 0 for x and y. This one's going to be 0, 1. This one's going to be negative 1, 0. All of these things work, and 0, negative 1 works. And I could find you some others, and we will, but not right now. Okay, can you graph this line? Well, I don't see why not. We should put the minus 4 on the other side, and we can get some points, like 5 gets me 4, and 8 gets me 6. And I should be able to plot 5 gets me 4. And I should be able to plot 8 gets me 6. Then I'm done. Will the marker last? Can we sketch this? We've been doing it all day. Y equals 3. My first jump is 4 units. My next jump is twice that, 8 units. I feel like I'm doing the same problem again. And I might be, for all I know. Might have done it on purpose. So 3, 4 gets me 7. 19, 20. Probably did that same problem earlier. Doesn't hurt to repeat it. 70 years later, 1990 gets me 8 and 3, 11. Almost out of marker. One more graph. Well, I know it's cup shape up. I know on the decreasing side is my y-intercept. I want minus b over 2a. I now know it's positive. So 4 into 40, 10 cut in half should be 5. When you do minus b over 2a, it should get 5. When I plug 5 in, I get minus 200. So therefore, I got minus 100 plus 7, which is minus 93. As far as I'm concerned, that's a good graph. If I want another coordinate, 0, 5, 10 should get me 7. And my root should be x equals 5 plus or minus. I start here, measure from there. And I've got to go up 93 to get to 0. So the square root of 93 divided by 4, which is the same thing as 5 plus or minus the square root of 93 in the numerator and 2 in the denominator. And now I am spent. That's it. Done. I'll probably be seeing these numbers in my head tonight. All right. There's lesson set 5. What happens when we get to 120 problems? I won't be talking at all. Just going to put the answers down. Hope you can find them. All right. See you in class on Monday. No, tomorrow. Choo-choo.